Hi guys, welcome back to the Gcse guide. Today we're going to be doing vectors AS and A level, and this is the ultimate guide. So I'm hoping that you guys remember the basics from GCSE. We're still going to be doing pretty simple stuff in this video, but I'm going to try and go over the whole entire chapter. So I'm not going to be doing too much depth for each topic, but we're going to be solving a couple of questions. And yeah, let's get right into it. So first of all, right off the bat, I just want to say that I will be using the edXL A-level textbook for this. So that is going to be my main source of information. To begin with, we're just going to talk about the basics. If a line PQ, a vector PQ, equals a vector RS, then these two lines are equal and they are also parallel. And then we're going to be talking about the triangle law. So if I have a triangle ABC, just going to try and go over these basics a little bit fast. Then AC, vector AC, which is right here. Oh, that was way too big. Okay. AC equals AB plus BC. Pretty straightforward stuff. Again, I'm hoping you guys know this from GCSE, but if not, it's not really difficult to understand. Okay, next we're going to be talking about if two vectors, or three vectors, it doesn't really matter, are parallel, then they can be written as multiples of each other. We're going to be doing notes as well as questions. I'm just going to write that over here. Notes and questions. Beautiful. Okay. So, next. In order to represent vectors, we can write vectors as column vectors, which would essentially be X and Y. And you can add your two vectors. For example, if I have 3, 4, 5, 9, you can just add them up to get the collective sum. Additionally, you can write any 2D vectors can be written, and this might seem a little bit confusing at first, as Pi plus Qj. I like to think of it as Xi plus Yj. So this number is your X component, this number is your Y component. So if I have a vector 3, 4, this is how it's written as a column vector. And in this form, it is written as 3i plus 4j. Pretty straightforward, nothing to worry about. And we've literally covered 2 out of 6 topics already. I know that sounds insane, but I'm going to do one practice question just so that we really get the hang of things before moving on to the third sort of subtopic. And there's, I think, collectively around 6, but it's a pretty easy chapter, you guys. It's nothing to worry about. So I'm going to do question number 10 of the exercise 11B. Let's begin. So we have, the question is, the resultant of vectors A and B is parallel to the vector C, and we have to find P. So I'm just going to write down the question really quick. The resultant of vectors A equals 3i minus 2j and B equals Pi minus 2Pj is parallel to C equals 2I minus 3J. Find P for part A, for part B, resultant AB. Okay, so A and B, sorry. Okay, so for finding P, the resultant of vectors, okay, so the resultant of these two vectors, A and B, is parallel, the resultant of these is parallel to C, so we have to find the resultant. So that would mean that I'm going to write these as a column. I feel like it makes it easier. Resultant is pretty much the difference in the two vectors. So it's 3, 2. A is 3, 2 as a column vector. And B is P negative 2P. And the resultant of these is parallel to 2, negative 3. So that means that, just give me 1 second, guys. Yeah, so the sum of these pretty much is going to be, this is vector C. So from this, I can tell that 3 plus P, we can make a simple equation using the x components. 3 plus P equals, and we talked about how when lines are parallel, they are a multiple of each other. I'm going to take my multiple as x equals x multiplied by 2, so just 2x. And 2 minus 2P equals negative 3x, and x is obviously the same, so I can literally just equate x. So if 3 plus P equals 2x, then 3 plus P over 2 equals x, and I'm just going to equate it here into my second equation. I've just rearranged my first equation, right? So I'm gonna input this into my second one. So 2 minus 2P equals 3, negative 3, times 3 plus P over 2. I've just inputted this value of x. So 2 minus 2P equals, I'm gonna need my calculator for this. Okay, we're just gonna do negative 3 times 3 by 2, negative 9 by 2 plus, minus 3P over 2. And I'm going to multiply the whole entire equation by 2. 4 minus 4P equals negative 9 minus 3P. Take this onto that side and that onto this side would give me, I'm going to change the color because I don't really like this. Would give me 5 equals P pretty much. So that is my value of P. And then they are asking us to calculate the resultant. I'm just going to give you guys a second to just look over this because it can seem a little bit intimidating, but it's just simple algebra, honestly. It's not really much to worry about. Okay, so we're going to move on to part B. we know that p equals 5, and they're asking us to find, this is part B right here, the resultant of A and B, and we already have an equation for this, so it would just be, the x component would be the resultant of A and B is going to be, 3 plus P is going to be my X, and 2 minus 2P is going to be my Y, and then you just input P equals 5, for which we will get 8 and -12 as a column vector. They haven't specified how to write it, whether they're asking as a column vector or in this form, so I'm just going to write it in both. Equals resultant AB. That's pretty much it. We're already done with 2 exercises. Okay, moving on, we're going to do exercise 11. We're going to do topic 11.3, which is our third topic. So let's go over the content. For a vector xy, the magnitude, and we represent magnitude by the symbol absolute magnitude, is given by root x squared plus y squared. You can kind of think of it as a distance formula, but I wouldn't really recommend that at the same time. And if you want to find the unit vector, so a unit vector, okay, first we have to kind of specify what that is. A unit vector is any vector with a magnitude of 1, an absolute magnitude, not an absolute magnitude, with just a magnitude of 1. So this equation here should be equal to 1 for a unit vector. So a unit vector in the direction of A is A over the magnitude. And this is going to make a little bit more sense when we do it. But essentially, if the magnitude of a vector is 5, so this right here, if it's equal to 5, let's say, then a unit vector in the direction of A is going to be A over 5, or 1 over 5A. Okay, so we're going to do some more questions on this topic. Sorry guys. How about, I'm just kind of thinking about what questions we should do. Let's look at exercise 11C. We are going to do question number, I want to do 60, so I'm going to do 60. And then we might do 9 and 11. And then I think I might film a separate video for the remaining 3 exercises just to not make this too long. So this is 11.1 to 11.3. Okay, we're going to do question number 60. So let's get right into it. The question is essentially, where did it go? God. So they're asking us to write certain vectors in column form, and they've given us a graph. In my next video, I promise I will put pictures of the questions so that I don't have to draw them out, but for now this will have to do. 60 degrees. And they're asking us to write these vectors in I and j, and also in column form. So we're going to start with I and j. In order to figure it out, we need to figure out these components, and pretty much how we're going to do this is, so we're going to start by figuring out the x component. So and I have this value right here and this. So I have the hypotenuse and the opposite, so it is going to be sine of theta. Sine of 60 equals x over 5. Don't know why my notes app is being all weird, but and therefore x equals 5 root 3 over 2. And to calculate y, I can just use Pythagoras because I feel like that's easier. So I'm going to do 5 squared minus x squared. I'm just going to input this into my calculator. Whole square rooted equals my y component. Just inputting this into my calculator. We're getting 25 over 4. So as a column vector, I'm just gonna pop that into my calculator. I just want to double check and make sure that it's correct. Yeah, okay. Yeah, so we're getting 2.5 as the y. Now it's really important that you look at your direction, because you might just immediately think, oh, the column vector is 5 root 2 over 2, and the y is 2.5. However, that is incorrect, because if we pay attention here, it's actually going downward. So it's going right, which is going to be positive in the x direction, but it's going downward, so the y is actually going to be negative. And then for the I and j form, it's just going to be 5 root 2 over 2, root 3 over 2, I plus 2 minus 2.5j. And that's pretty much it for 11.3. I hope this video helped, and if you guys have any suggestions, please let me know. Thank you so much for watching, and I'll see you guys next time.